All right, Owls, this is Mr. O with another set of flip notes. This is the second set. So we just got done with matter 6.P.2.2, which was basically all about the basics of matter and John Dalton and the atomic theory. Now we're moving into something that should be pretty familiar to you, which is properties and states of matter. And it'll also talk about the effect of heat on matter. Um, Remember, with flip notes, you have some cool things. Make sure if you have any questions, you write them down so you can ask me in class. Also, if you come across something and it just jots down an idea, you talk about that. We'll have that discussion as well. Also, when you're taking your notes, you're using the handout I gave you in class, and please write neatly and correctly, because if you can't read it, those notes will not be useful to you. Now, you have to listen to this whole note session, because there's going to be things you're going to have to do on the back, and there's nothing on the back, and you're going to have to make it yourself. So make sure you pay attention and listen through the whole thing. We're first going to start with the word property. I put this nice little sneaker right there, and the reason why I did that is because property, in scientific terms, is anything used to describe something. So if you talk about properties of matter, it's the things that we use to describe matter. So let's move on to the three properties of matter, and I emphasize this. If I were you, I'd write this in your notes in capitals. Do not confuse with three states of matter. One of the biggest things I see with students is I'll say, what's the three properties of matter? And they automatically say solid, liquid, gas. And I say properties, not states. So let's go with properties. And the first one is mass. And in parentheses, I'd put definite or no definite. Second one is shape, and that's definite, or volume, sorry, definite or no definite. And the last one, obviously, I just said was shape. Now, connecting with the states of matter, all states of matter have shape, mass, and volume. So if it says definite or no definite, let's use a solid, for example. A solid has a definite shape, definite volume, and definite mass, just like a golf ball, meaning every single time that golf ball is going to be the same size, same shape, same weight. However, the water in your water bottle is not going to have the same shape if you spill your water bottle on the ground. So it has a definite mass and a definite volume, but it has no definite or indefinite shape, which doesn't mean it doesn't have one. It just means that you can't always consistently measure it like the golf ball. So keep that in mind. We'll talk more about that in class. Now let's talk about the effect of heat on matter. This is something that seems like common sense to me, but we are going to talk about that. Atoms, they do two things. They move faster and spread apart when heat is added. If you're going to get something warmer, they're going to move faster and spread apart. Or they're going to move slower and closer together when heat is taken away. And I show you this picture of solids, liquids, and gases. And those are the molecules of water, actually. And if you look all the way to the left, that's what molecules of water look like near an ice state. And then if you look all the way to the right, that would be when water's boiling and turn into water vapor. They would spread out, and those molecules would stay the same look. They would just spread out and move faster. Let's talk about something you've been talking about since kindergarten, change in phase. Change in phase is the movement of atoms can lead to a change in phase. For example, a solid turning into a liquid. And I have this little fancy chart here with these really big sciencey words. And you don't need to know the sciencey words on the arrows, but you do need to know that solids, if they turn into a liquid, that's called a change in phase or a change in state. It's the same thing. State and phase are the same word. A lot of elements can go through all states of matter, meaning they can go from a solid to a liquid to a gas, but there are some exceptions. You think of liquid nitrogen or dry ice. It goes from a solid to a gas. There is no liquid state to dry ice. So it depends on the actual element or elements dealing with it, but a lot of them can do different things. And we'll use water a lot as an example, and water as solid is ice, and liquid's water, and gas is water vapor. So, yeah, moving on to state of matter. State of matter. This is something you also have been learning about since you were in kindergarten. States of matter, nothing new, solid, liquid, gas, and also I would add in plasma. There's other couple states of matter that we'll talk about, but I'd like to remind you that there's not just three. You've been told there's three states of matter since the beginning of time. That's not true. They just did it to make it easier for you. Plasma, I mean, like the sun and the light bulbs in the classroom that aren't on in my room, but they're on in other teachers' rooms. They are plasma. It's electrified gas. But it's also the adding or removing heat can change the state of matter, meaning these states of matter is all about based on heat. And I use this nice little illustration of one snowman being robbed by the other because the fear of heat would change his state of matter. Now, this is where I told you on the back of your notes that you need to write things down, and there's nothing on the back of your notes that says, here, write this information here, except for me telling you on this note, so just follow my directions and write these on the back. First of all, definite means measurements that stay consistent. Remember we talked about shape, mass, and volume, definite, not definite. Those are consistent measurements, meaning they can always be found the same. No definite means measurements that may change but are still measurable. Doesn't mean they don't have one. It doesn't mean that you can't find one. It just means that when you find it one time, the next time you find it, it may not be the same. And now you're going to build a beautiful chart. And you're going to build a 3-column chart, solid, liquid, gas. Okay. And in this chart, you're going to talk about what makes a solid unique, what makes a liquid unique, and what makes a gas unique. And what makes a solid unique is it means it has a definite shape, mass, and volume. Remember my golf ball example. A liquid has a definite mass, a definite volume, but no definite shape because it takes the shape of the container. And gases have no definite mass, no definite shape, and no definite volume. If you look at solids and gases, they are complete opposites of each other. And the liquid's the tricky one because it's got 2 of one and 1 of the other. A couple quick examples. Pencil or table for a solid, water, milk, and water. And examples for gas is the air you breathe, and carbon dioxide, the air you exhale. One tricky thing I see often, students think that gasoline that goes in cars is a gas because it has gasoline in it. It's actually a liquid. Just keep that in mind. But these are your notes. Any questions, ask me when you get back to class, but make sure you have these complete and readable so you can use them throughout the unit.